Today, we will look at scale factors and areas of two-dimensional shapes. So, example. Barrett's aunt has a garden that measures 16 feet by 10 feet. She decides to double the length and width of the garden. What are the new dimensions of the garden? Yes, 32 feet by 20 feet. So, part A. $32 by 20. B, what's the new area of the garden? What would the area of the garden, the new garden, be if everything gets doubled? Area is length times width, so it's I like 640 square feet better for the area of the new garden. Part C, how does the new area compare to the old area? Well, the old area, although it wasn't calculated, was 16 by 10, which is 160. So old area to new area. How do you spell new? Not with an N and an E. We need W2. So that's 160 to 640. So what we basically have to ask ourselves is, how many 160s are there in 640? Yes. Yes. So in other words, the area is 4 times the old area. Okay? We're going to repeat parts A to C using the idea that Barrett's aunt doesn't double the dimensions of the garden, but she triples the dimensions of the garden. We're going to repeat parts A to C in part D, but instead of doubling, we are tripling. Okay? Sky, are you still writing this down? Are you copying some stuff down? Okay, so I'll give you a second. Oh, okay. Okay. Tripling. So what are the dimensions if we triple the original dimensions of the garden? 48 by 30. So 48 feet by 30 feet. Now the new area would still be length times width. And that's 48 times 30, which, if my math is okay, is 1,440 square feet. And then we have to compare this number to the original area. What was the original area of the original garden? 160. So now we're going to go old area to new area. So old area to new area. So we're actually taking that 160 and now we're comparing it to 1440. So you know what? I'm going to ask you this question. How many times does 160 go into 1440? 9. It does go 9 times. Indeed, indeed. So it's 1, to 9. What we've just done is we've explored a couple things here. Here's what we've done. We looked and saw that if we doubled the dimensions, the length and the width, that the area gets multiplied by what? 4. And if we triple the dimensions of the garden, then the area gets multiplied by, okay. So what if I multiplied the dimensions by 5? The area would get multiplied by, correct. So let's generalize it into super fancy math terminology. If we multiplied the dimensions by a letter n, then we would multiply the area by n squared, exactly. So there's our rule. There's our rule. So what we can say is this, and we'll get really mathematical here. We'll say that if the scale factor for the dimensions, I'll put bracket length, is n, then the scale factor for the two-dimensional, which is today's topic, areas, is n squared. So we could be talking about a three-dimensional object, but talking about surface area, which is still a two-dimensional thought. Anything two-dimensional, if we multiply, I just printed it today. Oh no, I made that one probably 6-8 years ago. So if we multiply the lengths by n, then the scale factor for the areas is n squared. Make sense? Okay. Let's go. 2 examples, or I lied, 1 example. Here it is. A scale diagram of a rectangular park. So the diagram itself is 12 by 7.5 centimeters. The area of the actual park is 1,440 square feet. Okay, it's a pretty small park, but that's okay. Find the scale factor of the diagram to the actual park. So we're looking for the scale factor of the diagram to the actual park. Now it doesn't say areas, so we're gonna assume that we're gonna be talking about measurements or one-dimensional. Okay. Now we'll have to find the reverse, but we'll go from there. So the first step is we got to find the area of the scale diagram. Okay. Got to find the area of the scale diagram because that's going to help us find the scale factor. So the area of the scale diagram is 12 times 7.5, which I think is 90. 90 centimeters squared. Okay. Now this question, oh gosh, this question's ugly. This question's ugly, really ugly, because, oh gosh, I don't know if I want to do that. If we're looking for a scale factor, we can't say 1 centimeter to 2 feet or something like that. We just have to come up with a number. So for that reason alone, what we have to do, we can still do this, but we're going to have to do something just slightly different here. We're going to have to divide this by 2.54 and divide this by 2.54 to find the area in square inches. So what is 12 divided by 2.54 times 7.5 divided by 2.54? That'll give us the answer in square inches. 4.72 is our final answer. That might be what you get. What's that? That sounds better. No. You could just go this divided by this times this divided by this. Okay? So 13.95 inches squared. Okay? And it's important that we are in the same type of measurement, either both in metric or both in imperial. Because now we can compare that to a 1440 square feet a lot easier to find a scale factor. So what I can do is we can take 13.95 inches squared and I can compare it to 1440 square feet. Now, the thing of it is though, I have to take this and convert it into square inches. Okay, but it's not as easy as you might think. Okay, it's not as easy as you might think because 1 foot is how many inches? 12, and that's pretty straightforward. But if we have a square foot is actually 144 square inches. So we're going to take this and we're going to multiply it by 144 to turn it into square inches. So we have 13.95 inches squared to 1440 times 144, and the answer will be in inches squared. What is 1440 times 144? 207,360. Okay, remember this is just to find the scale factor for the area. Well, to find the scale factor of the measurements, and we'll do both. There's still a little bit of math involved, and we'll get there. So to find the scale factor, what we basically have to have is we have to have a ratio where the first number is a 1. It's 1 to something, okay? So to make this a 1 to something, we basically now have to divide both these numbers by 13.95. So 13.95 divided by 13.95 is just 1 inch squared. But what's that 207,360 divided by 13.95? Okay, so this is the scale factor. This is the scale factor, 0.52. Okay. This is the scale factor for the area. Okay. This is the scale factor for the area. If we want to find the scale factor for just measurements, what do you think we'd do with these numbers? Well, technically, okay, technically the scale factor for the areas will be 14,864.52. Okay, that's a scale factor for the areas. But I'm asking you what the scale factor is for the measurements. How do we find that? I can't hear you. How do we reverse it? Nope. I want us to go back. This is the scale factor for the areas. What's the scale factor for the dimensions? No, we have to find the scale factor for the dimensions, and then we find the dimensions. What do you think we do? Nope. Hint. Nope. Hint. Hint. If the scale factor for the measurements is doubling, what's the scale factor for the areas? No. Yes. If the scale factor for the dimensions is 3, what's the scale factor for the areas? Yes. Oh, there we go. There we go. We find the square root. We find the square. Well, it scared me that we didn't know that. So that makes maybe 3 of us that were scared there. So, well, that's good. Scale factor are the dimensions. That's really bad penmanship, even by my own low standards. The scale factor for the dimensions is the square root of 14,864.52. And what is that? 121.92. So what this means is the length and the width of the real park is 121.92 times bigger than that of the scale. Okay, that's what that means. So we're kind of working backwards here. Now, that's part A. Part B is really easy. We did all the work in part A. Part B says find the dimensions of the park. Okay, find the dimensions of the park. So part B is really easy. You know why it's really easy? Because we have the scale factor, all we have to do is take 12 centimeters and 7.5 centimeters and multiply them both by 121.92. So we did all the heavy lifting here. We already did all the heavy lifting. But so we're going to take 12 centimeters times 121.92. Now, here's the deal. This is a unique question because the scale was given in metric and the real thing was given in imperial. So we could do some conversions here, but we won't bother too much with that quite yet. What is 12 times 121.92? So that's centimeters. Now, it might make some sense to at least change that to meters. If we're not going to change that to feet, at least change that to meters. Changing it to meters is a piece of cake. How do we change that to meters? How many spots? Good. So it's 14 points. We can even just write this as, I'd say 2 decimal places is fine. 14.63 meters. That's good. Okay. And then we do the exact same thing with the 7.5. We take 7.5, multiply it by 121.92. So what is 7.5 times 121.92? 914.40 centimeters, which if we move the decimal gives us 9.14 meters. Okay? So the dimensions of the real park are 14.63 meters by 9.14 meters. Dunzo. Any questions about that? All right.